So we thought we would end this chapter by putting together a little video with a review of everything that we've covered. We're going to start by reviewing the 3 different ways that we've learned how to graph lines. So the first way was we made a table. Now when you're going to make a table, your first step is going to be to rearrange this equation to get y by itself. So we would have y equals negative 2x plus 6. Then we would make a table of x and y values. And we can choose any numbers we want for x, and we're going to plug those numbers into our equation to calculate our y's. So if I take negative 2 and I plug it into my equation, I get 10. If I take negative 1 and I plug it in, I get 8. If I plug in 0, I get 6. If I plug in 1, I get 4. And if I plug in 2, I get 2. Now I'm going to graph these points on the graph. And I get negative 2 comma 10 goes here, negative 1 comma 8, 0 comma 6, 1 comma 4, and 2 comma 2. Now I'm going to use my straight edge to connect my dots. I'm going to go beyond the edges of the graph and put arrows, and I'm done. The second way we learned how to graph these equations is using X and Y intercepts. Now you'll notice that we're starting number 2 with the same problem as number 1. What I want to show you here is that even if we graph this using a different technique, we get the same end result. So we're going to want to find the X intercept, and we're going to want to find the Y intercept. Now in order to do this, we said we used the cover-up method. So for the X intercept, we cover the Y, and for the Y intercept, we cover the X. So if I cover up the Y, my new equation would be 2x equals 6. If I divide by 2 to get the x by itself, I get that my x-intercept is 3. If I cover up the x term, I just get y equals 6. Now I'm going to graph on the x-axis at the positive 3, on the y-axis at the positive 6, and I'm going to draw a line through those points that goes beyond the edges of the graph and has arrows on both ends. The last way that we learned how to graph was using something called slope-intercept form. In other words, y equals mx plus b. So the first thing we would need to do here is get the y by itself. So we would get y equals negative 2x plus 6, which means my slope and my y-intercept would be negative 2 and 6. We're going to begin at the 6 on the y-axis. Then we're going to use the slope to move. So instead of writing negative 2, I'm going to write negative 2 over 1, which means from this red dot, go down to right 1, down to right 1, down to right 1. Once we're done and we run out of room, we can go back to the top and we can go up to left 1, up to left 1, and then use a straight edge to draw a line that goes through those points, goes beyond the edges of the graph, and has arrows. Now if you look back at these 3 lines, you'll notice they're all exactly in the same spot on the graph. So all of these techniques are just ways to make the graph, but at the end it results in the same picture. Then we started learning about vertical and horizontal lines, and we said the magic word was vuxhoi. So in problem number 1, where we have x equals negative 4, I would think about vux, which means it's going to be a vertical line. So on the x-axis, I would put a point on the negative 4, and then I would draw my vertical line. For problem number 2, where it says y equals 3, I would think about hoi. So because there's a y, I would draw a horizontal line. On the y-axis, I would put a point on the 3, and draw a horizontal line through that point. Next, we talked about slope. So to find slope, we're going to calculate two things. We're going to look at the rise and we're going to look at the run. So I can start at either one of these points. Let's say I decide to start here. To get to the other point, I would have to go down 2 spaces. So my rise would be -2. Then I would need to go left 4 spaces. So my run would be -4. Now -2 over 4 reduces to +1/2. And after we learned about slope, we said that sometimes we can actually put units on our slope by looking at the rise and the run. So in the next picture, my slope would be down 3, and the units would be meters. And then I would go over 1, and the units would be seconds. Then we started talking about functions. Now, we had some tests to determine whether we have a function or not. We said everyone can only go to one party. And we said when there's a graph, we use something called the vertical line test, which means we're going to draw a vertical line and we want to make sure it only touches the graph once. Since these vertical lines touch the graph in 2 spots, we would say that this is not a function. Now if I check this table, 2 is going to 1's party, -2 is going to 3's party, 4 is going to 5's party, 1 is going to 7's party, everybody's only going to 1 party. So we would say that this is a function. Lastly, we started talking a little bit more in depth about functions. So we said that in this problem where the number is inside of the parentheses, it's an x value. So everywhere that we see an x in the original equation, we're going to replace it with -2. So we're going to have f of, and instead of x, we're going to write -2. Equals 2 times, instead of x, we're going to have -2 minus 3. Which means our answer is that f of -2 is equal to 2 times -2 minus 3 is -7. And that this notation means that the name of the function is f, that the x value is -2, and that the y value is -7. Next, we said sometimes we could be asked to calculate an x value. So it says find the value of x so that f of x is -13. Because this is outside of the parentheses, it's a y value. So we would put it where we would normally put a y. And we would have -13 equals 2x minus 3, and we would solve. So we would add 3 on both sides, and we get -10 equals 2x. Then we would divide by 2, and we would get -5 equals x, and that's our missing x value. Which means we could write f, which is the name of the function, of x, which is the number we just calculated, equals the y, which we already knew was -13. Next, we looked at function notations and graphs. So we said f of 1 means x is 1. So if I go on the graph on the x-axis to where the value is 1, I can see the y value there is 0. If I go on the graph to where the x value is -3, I can see the y value there is 2. If I go on the graph to where in this problem the y value is 3, I can see the corresponding x value is -2. And if I go on the graph to where the y value is -1, I can see the corresponding x value is 0. Oh, you can't see what I wrote for that one. 0. Last but not least, we talked about domain and range. So domain is always the inputs. Range is always the outputs. And that was pretty much it. That's the whole chapter in a nutshell. So thank you so much for watching. I appreciate it. I hope you have a great night, and I will see you tomorrow for some chapter review and practice.